Hi guys, welcome to my Learning Mechanics series for beginners. This series is aimed at students who have just started learning mechanics, and in this series we will be going through the basics of mechanics. It'll be a 10-part series or maybe more, I'm not too sure at this stage, and hopefully at the end of this series you will be able to solve more complicated problems on your own. So in this first episode we will be looking at scalars and vectors. So scalars and vectors are just two categories where we can put different things that we measure into each category. So what do I mean by this? So let's have a look at what a scalar is first. So scalars are physical quantities you can measure, such as distance, speed, and time, but they only have a size associated with them. For example, distance measures how far away you are from a place. I could be 10 kilometers away from the airport. So here I have an airport and I could be 10 kilometers away from the airport. That means I could be located over here or I could be located over here. It doesn't matter. In both scenarios, I'm 10 kilometers away from the airport. So my distance between me and the airport is 10 kilometers. Another example is time. So, and time is just how long it's been since you started measuring. So, for example, it took Usain Bolt 9.63 seconds to run 100 meters. These quantities only have a size associated with them. They don't have an additional property, direction, which is what makes the difference between a scalar and a vector. So let's have a look at what a vector is now. Vectors are scalars, but with an additional property, direction. So let's look back at the previous example with the airport. So I said that the distance between me and the airport is 10 kilometers. Okay. Now if I wanted my friend to pick me up from this location, it's not very helpful to him because I could be on a circle of radius I could be anywhere on a circle of radius 10 kilometers centered at the airport. I could be anywhere on the circle. It doesn't matter because each point is 10 kilometers away from the airport. Again, this is the scalar quantity of distance. To convert this into a vector, we have to give a direction from the airport to where I'm located. So for example, I could be located 10 kilometers away from the airport, exactly north. Okay, so now, or I could be 10 kilometers exactly west. Okay, so now not only do you know how far away I am from the airport, but you also know exactly what direction you must travel to reach me. And this pinpoints your location. So in this case, the scalar is distance and the vector is called displacement. Let's have a look at another example. In this example, let's say we are an air traffic controller and we're trying to help a plane, we're trying to guide a plane to land at the nearby airport. And for whatever reason, the pilot is struggling. So not in addition to how fast we can tell the pilot to land, so we can say, okay, a reasonable speed to land the plane is, I don't know, 150 meters per second. But if we just say, okay, you need to land at speed of 150 meters per second, okay, but in what direction? It could be in any direction. What direction must the pilot direct the plane? So in addition to the speed, we can also give a direction. We could say, okay, you need to travel at 150 meters per second at a bearing of 60 degrees, for example. And if you do this, then you will be headed directly towards the runway. So in this case, we have speed, which is a scalar component, and velocity, which is its vector component. So let's have a look at some common examples of scalars and vectors. So what we looked at before was distance, which is just the distance between two objects. It's a scalar component and it's measured in its SI unit is meters. Its vector component is displacement, which is how far you are from an object, and also the direction you must travel to reach me. So that is also measured in meters. And we also looked at speed, which is how fast you're moving. Its unit is meters per second. Its vector component is velocity. So again, velocity is just how fast you're moving and in what direction you are moving. Other scalar quantities are mass, which is how many kilograms an object is made of. It's basically how much stuff an object is made of. I could say that an object has a mass of 2 kilograms, but it doesn't make sense for me to say it has a mass of 2 kilograms in a direction north or something. It doesn't make any sense. There is no direction associated with it. It's just a scalar. We also have energy, which is measured in joules. So, for example, how much kinetic energy, how much gravitational potential energy, chemical potential energy, elastic potential energy, whatever. We'll come to some of these in future videos. And lastly, we have time, which is just measured in seconds. So, like I said before, it took Usain Bolt 9.63 seconds to run 100 meters. Uh, that's just how long it's been. It doesn't matter what the direction is here. And some more vectors are acceleration, which is the rate of change of speed. So let's say I'm at point A and I'm traveling at 5 meters per second, and then at point B, I'm traveling at 10 meters per second. So my speed has changed, so I've accelerated. So its unit is meters per second squared, or you can think of it as meters per second per second. So how much your speed is changing per second. And we'll also come to this in future episodes. And we have force, which is a vector. So you're applying a force to an object, causing the object to accelerate. You could be pushing it, you could be pulling it. And also the direction you're pushing or pulling it will dictate the direction it accelerates. And we also have momentum, which is an object's mass times its velocity. And another thing you just want to note, with acceleration, the speed may not necessarily need to change, but if the object's direction changes, it is also accelerating, even though its speed may be constant. But we'll get to this in future episodes. So now I have a few questions for you guys down in the comment section below. Question number 1 is, give your own definition of scalars and vectors. If you can define it in your own way, which makes sense to you, that's great. A second question is, do all scalars have a vector component? Okay. And do all vectors have a scalar component? And give a few more examples of scalars and vectors. So just put your answers down in the comment section and we'll see what you get. All right. Thank you for watching. See ya.